Hi everyone, welcome to my YouTube channel Zenith GATE Mechanical. So in the today's session, I will discuss the question which was asked in the GATE 2025 engineering science paper from the solid mechanics. So this is the first question which is related to the relationship between the elastic constant. Okay, so the question is for a certain linear elastic isotropic material, the modulus of elasticity is given as 140 gigapascal and the shear modulus, which is denoted with a G symbol, is given as 50 gigapascal. The Poisson's ratio of the material you have to find out and do the round off to 2 decimal places. Okay, so the data given is the Young's modulus is given as 140 gigapascal. The shear modulus, which is denoted with a G symbol, which is nothing but 50 gigapascal. The Poisson's ratio value you have to calculate, okay, which is nothing but the ratio of the lateral strain to the longitudinal strain. That is nothing but mu value. Okay. So for solving this problem, there is a relation between the elastic constant, that is nothing but E is equal to 2G 1 plus mu. If the shear modulus and the Poisson's ratio is given, then you can use this formula for calculating the value of Young's modulus. But if the bulk modulus is given, and the Poisson's ratio value is given, then you can use E is equal to 3K 1 minus 2 mu. Okay. But for this particular question, you have to calculate the value of Poisson's ratio. This G and E value is given. Okay. So that means you have to use this first formula. So E is equal to 2G 1 plus mu. So what is the value of E? This is nothing but 140. And G value is also is given in gigapascal. That means 50 into 2, 1 plus mu. So this will become 140 divided by 100 is equal to 1 plus mu. So from here, the mu value will be 0.4. Okay. So the correct answer for this question is mu is equal to 0.4, which is nothing but the Poisson's ratio. Okay. So let's move to the next question, question 2. The two-dimensional state of stress is given. The sigma x value is 800 megapascal, sigma y is 0, and sigma xy, which is nothing but the shear stress, tau xy, is given as 300 megapascal. Which one of the following option is the maximum shear stress in an element? So you have to calculate the maximum shear stress in that particular element. And for that, the two-dimensional state of stress is given, which is nothing but the sigma x, sigma y, and tau xy. It is given in the question. Okay, so first of all, you have to calculate the principal stress value. But how you will get the principal stress value? So there is a relation for the principal stress. Sigma 1, 2 is nothing but sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau square xy. Okay. So where the sigma x, sigma y, and tau xy is given in the question. So sigma x is given as 800 megapascal. Sigma y is given as 0. Tau xy is nothing but 300 megapascal. Okay. Just put this value, then you will get the sigma 1 and sigma 2. Okay. So for 1, you have to use the plus sign, and for 2, you have to use the minus sign. Okay. That means sigma 1 is the major principal stress. Sigma 2 is the minor principal stress. So sigma x value 800 plus 0 by 2 means 800 by 2 plus minus 800 minus 0 by 2 whole square plus tau square xy means 300 square. So this is 400 plus minus this is 400 square plus 300 square. So 400 square, 300 square root is nothing but 500 only. So 400 plus minus 500. Okay, now sigma 1 and sigma 2 you can easily calculate. Sigma 1 is nothing but 400 plus 500, which is nothing but the 900 megapascal. And sigma 2 is 400 minus 500, which is nothing but minus 100 megapascal. Okay. But you have to calculate in the question, what will be the value of maximum shear stress? What will be the value of maximum shear stress in an element? So for that, the maximum value of shear stress is nothing but the maximum of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, and sigma 3 minus sigma 1 by 2. Okay, so whatever the maximum value of out of these three terms, that will be the answer. So, but first of all, what is the sigma 3 value? It is a biaxial state of stress. That means sigma 3 value will be 0 because it is already mentioned. Two-dimensional state of stress means sigma 3 value will be 0. So, sigma 1 minus sigma 2 by 2 is nothing but, so maximum of 900. Sigma 2 is minus 100, so that will become plus 100 by 2. Sigma 2 is minus 100 minus 0 divided by 2. And this value will be 0 plus 100. This value will be 900 divided by 2. So now this value is maximum of 500, and this is 50, and this is 450. Now what will be the correct answer? The maximum value of stress out of these three, what is the maximum value? 500. So the correct answer will be 500 megapascal. 500 megapascal. 500 megapascal. That means choice C is the correct answer. Choice C is the correct answer. Okay, so now move to the next question. A beam is having the square cross section. The length of outer section is 10 millimeter. Okay, and the thickness is 1 mm as shown in the figure. You have to calculate the area moment of inertia of section about the x-axis. A very simple question. So you have to calculate the moment of inertia. Okay, so a beam is there whose cross section is a square. Now the outer section, the length of the outer section is 10, and the thickness will be this one. That means it is a hollow section, hollow square cross section. You have to calculate the moment of inertia. So how you will do? First of all, you know that moment of inertia of square cross section is nothing but a to the power of 4 by 12, where a is the side of the square. So if you want to calculate the moment of inertia of this portion, what you will do? You will take the moment of inertia of outer minus the moment of inertia of inner one. Then you will get the moment of inertia of this hedged portion. So the moment of inertia of the required or the shaded portion is nothing but 10 to the power of 4 by 12 minus, what is this distance? This is 1, this is 1. That means this distance is 8 mm. Okay. So this will be a to the power of 4 by 12. So once you will solve, then you will get the answer 492 millimeter to the power of 4. So this is nothing but the moment of inertia about the x-axis. Moment of inertia about the x-axis. And you have to answer in the integer. So the correct answer for this question is 492. 492. Okay, so the next question is, this question is basically related to the thermal stress concept. Now, a bar of length 1 meter is fixed at one end. Before heating, its free end has a gap of, this delta value is given as 0.1 mm from a rigid wall as shown in figure. Now the bar is heated and resulting in a uniform temperature rise of 10 degrees centigrade. Now what you are doing, you are increasing the temperature of this bar to this particular temperature. The coefficient of thermal expansion is given as 20 into 10 to the power of minus 6 per degree centigrade. And the modulus of elasticity is also given. assuming the material property do not change with the temperature, the magnitude of axial stress you have to calculate. Okay, so first of all, understood this particular question, what is happening? What is the data given? The length of bar is given as 1 meter and the delta value is given as 0.1 millimeter. Okay, how much you are rising the temperature? By 10 degrees centigrade. Okay, so if you are increasing temperature by 10 degrees centigrade, what will be the thermal deformation? You know the thermal deformation is nothing but alpha delta T into L. So first of all, you will calculate what will be the thermal deformation. So that means after increasing the temperature, how much this length is increasing, which is nothing but alpha delta T into L. So this is 20 into 10 to the power of minus 6. Delta T is given as 10 and L is given as 1000 because it is given as 1 meter. So it will become 1000 millimeter. So that means the delta L thermal, that means the thermal deformation is 0.2 mm. Okay, now if you see, if you are increasing the temperature of this bar, it is expanding 0.2 mm. But this gap is only given as 0.1 mm. That means it is trying to elongate 0.2 mm. But because of the rigid support, what will happen? It will only extend till 0.1 mm. That means there will be a reaction. And whenever there is a reaction, that is nothing but the reaction offered by this support. That means this bar will experience some kind of internal forces, so which will result into the stress. And that stress, basically, you have to calculate, which is nothing but the axial stress. Okay, so the total deformation which is allowable is 0.1. So I can write here the total deformation is 0.1 mm, which is nothing but the total thermal deformation plus total axial deformation, which is equal to 0.1, So thermal deformation you already have calculated, which is nothing but 0.2 value, 0.2. What is the axial deformation? Axial deformation is nothing but sigma L divided by E is equal to 0.1. Why? Because this is basically your bar whose one end is fixed. Now, when you are increasing the temperature, this bar will experience some kind of reaction from here. Let us suppose it is expanded till here. So because of this axial force, what will be the stress? What will be the deformation? The deformation is nothing but sigma L by E. So why I have added this minus sign? Because this is a compressive. So 0.2 minus, what is the value of length? Length is given as 1000. The Young's modulus is also given in gigapascal, so you will convert into megapascal. So 100 into 10 to the power of 3 is equal to 0.1. So this is nothing but sigma into 1000 divided by 100 into 10 to the power of 3. So 0.2 minus 0.1 is 0.1. So this will be cancelled out. Okay. Then you will get the sigma value is 0.1 into 100, which is nothing but 10 megapascal. So that means the axial stress which you are getting is 10 megapascal. 10 megapascal. Okay. So actually this stress will be in the compressive, but in the question clearly mentioned, you have to mention the answer in the magnitude form. That means the magnitude of resulting axial stress on the bar is 10 megapascal. Okay.